Okay, our topic is finding the general term or the nth term. So we have here the given 25, 50, 75, and 100. So our first term here denoted by n. So we have first term is 25. Our second term, which is 50. Our third term is 75. Our fourth term is 100. So the following are our a sub n. Let us first try to get the difference between the succeeding terms. So we have, so the difference between 100 and 75 is 25. 75 and 50 is 25 also. 50 and 25 is 25 also. Since the difference is a constant, which is 25, the general term is linear in nature. So the linear equation in one variable n can be the form. So we have an plus b is equal to a sub n. Okay, so let us now try to use the first one. The value, which is n is equal to 1, then our a sub n is equal to 25. So this can be written as a plus b is equal to 25. Now, getting here 2 as the value of n and a sub n is 50. So we have here, so n is equal to 2. Our a sub n is equal to 50. So we have 2a plus b is equal to 50. Now, subtracting equation 1 from equation 2. So this is our equation 2. This is our equation 1. Let us try to use elimination method. So we have 2a plus b is equal to 50. Then we have a plus b is equal to 25. Okay, I'll be changing the sign here below. So this will become negative. So 2a minus a, we have here a. Since b and negative b, that will be cancelled out. So we have the value 50 minus 25 is equal to 25. So we have here the value of a, which is equal to 25. Now, let us try to substitute the value of a into the equation 1. So we have a plus b is equal to 25. So the value of a, which is 25, plus b is equal to 25. Transposing negative 25 here to the right, so we have b is equal to 25 minus 25. So we have the value of b, which is equal to 0. Okay, now, so a is 25, b is equal to 0. So let us now try to substitute it. So we have 25n plus 0 is equal to an. So we have 25n is equal to a sub n. So we can rewrite here a sub n is equal to 25n. That is our nth term. Okay, let's have another example. So we have 2, 3, 5, 8, and 12. So here, these are our a sub n. So if our n here is 1, so we have our a sub 1 is 2. So we have here n is 2, our a sub 2 here is 3, and so on. So this is our third, fourth, fifth term. Okay, so a1, a2, a3, a4, a5. So these are the values. Okay, now let's try to get the difference of the following succeeding numbers. So the difference between 12 and 8 is 4, 8 and 5 is 3, 5 and 3 is 2, 3 and 2 is 1. So we have noticed that the difference are not the same. Okay, so it's not a linear function. So let's try to continue getting the difference. So the difference of 4 and 3 is 1, 3 and 2 is 1, 2 and 1 is 1. Okay, now, since we have the second difference are the same, so it can be considered as a quadratic function. So in the quadratic function, we have ax squared plus bx plus c is equal to 0. Okay, so let us just try to replace the x as n. So an squared plus bn plus z is equal to our a sub n. Okay, now, if our a1, which is equal to 2, our n is equal to 1 here. Okay, so we have, let's try to substitute here to the formula. So we have a 1 squared plus b times 1 plus c is equal to the first value, which is 2. Okay, so 1 squared is 1 times a, which is a, plus b times 1, which is b, plus c is equal to 2. That is our first equation. Okay, now our a sub 2 here, which is 3, and our n, which is equal to 2. Okay, so let's try to substitute this to the given equation here. So we have a, so we have the value of n, which is 2 squared, plus b, the value of n times 2, plus c is equal to 3, the second term. So simplifying this, 2 squared is 4 times a, which is 4a, plus 2b plus c is equal to 3. That is our second equation. Okay, now our a sub 3, so here our a sub 3, then the value of n, which is equal to 3. So we have here 5, then n is equal to 3. So let's try to substitute. So a times 3 squared plus b times 3 plus c is equal to 5. So 3 squared, which is 9, times a, which is 9a, plus 3 times b, or b times 3, that is 3b, plus c is equal to 5. That is our third equation. Okay, so subtracting equation 1 from equation 2, let us try to subtract. So we have 3a plus b is equal to 1. Okay, then subtracting equation 2 from equation 3, so we have 5a plus b is equal to 2. Okay, now let us now try to use elimination method here, subtracting equation. So this is our equation 4 and equation 5. Okay, so subtracting equation 4 from equation 5, so we have 2a is equal to 1. So dividing both sides by 2, so we have our value of a, which is equal to 1 over 2. Okay, so let us now try to substitute the value of a here on the fourth equation. So we have 3 times 1/2 plus b is equal to 1. So we have here 3 times 1/2 is 3 over 2. Transposing it to the right, so we have b is equal to 1 minus 3 over 2. So I'll be solving bad boy method here. So b is equal to 2 times 1, or 1 times 2 is 2, minus 3 all over 2. So we have the value of b, which is negative 1/2. So we have a and b already. So let us now try to solve. Let us try to substitute using the equation 1. So the value of a is 1/2 plus the value of b is negative 1/2. So minus 1/2 plus c is equal to 2. So 1/2 minus 1/2, that will be cancelled out. So I have here the value of c, which is equal to 2. So now I have already the value of a, I have the value of b, then I have the value of c. Okay, so we have here the value of a, which is equal to 1/2, b is equal to negative 1/2, and c is equal to 2. Let us now try to substitute these following values on the given quadratic equations. So we have here a, 1/2 n squared, plus bn, so negative 1/2 n, plus the value of c plus 2 is equal to a sub n. Now we have noticed that we can factor out 1/2 here, so I'll be pulling out 1/2. So 1/2 n squared divided by 1/2, that is n squared. Negative 1/2 n divided by 1/2, that is negative n, plus 2 divided by 1/2, the answer is 4, is equal to a sub n. So we can rewrite this as a sub n is equal to 1/2 times the quantity n squared minus n plus 4. So this is now our general term.